Hey guys, okay, so we're going to be talking about the summation notation. Now this is the summation notation, and for this problem, 46 is the number going up to, and I equals 1. So we know that this is an arithmetic series, and for those who don't know what that is, it's by adding the same number each time to the problem. So we have Sn equals n, a1 plus a2 over 2, that's the arithmetic series formula. Sn equals 46, 1 plus 46 over 2, and then 46, and we just took, plus 47 divided by 2, which will be 235 times 46, which is 1081. And that's it. Okay, so we're going to be looking at the sum of squares. Now the sum of squares is used when the arithmetic and geometric formula cannot be used. In order for it to be arithmetic, you have to add by the same number each time. And in order for it to be geometric, you have to multiply by the same number each time. So here we have this. This goes up by 3 and this goes up by 5, which means it can't be arithmetic or geometric. And so here we have the formula for the sum of squares, n, and then n plus 1 times 2n plus 1 over 6. This is the number of terms, this is the number of rows. So we just add it in. So the number of rows for our problem is going to be 15. And with the number of terms, yes. And then we have 15 plus 1, it's the same number of rows actually. And then divided by 6. And then 240 times 31 divided by 6, which will be 7,440 divided by 6, which is 1,240.
I'm going to be explaining geometric sequence and arithmetic sequence. For the geometric sequence, the AN stands for the last term. The A stands for the first term. The R is a common ratio, like times 2. And the N is for the number of terms. Once you plug in the numbers appropriately, you work it out like any other equation. 6 minus 1, 5, and 2 to the 5th, times 4. Simple enough. For the arithmetic sequence, basically same thing. Last term, first term, number of terms, and the common difference, which would be plus 4. Again, you just plug them in. Simple enough. Simpler than even the last one. 6 minus 1, 5, times 4, plus 4, 24. That's all there is to it.
Woo! Alright, pyramid scheme. Let's say that a pyramid scheme began with 3 people. Those 3 people recruited 3 new people every round, and so on. How long would it take for everyone to join in? So, first we need to figure out which formula do we use. We realize that it's the geometric series, so you use the corresponding formula, which is Sn equals A1, 1 minus Rn divided by 1 minus R. Sn is the sum of terms, of course, A1 is the first term, and R is the common ratio, and the number of terms is n. Okay, there are roughly 300 million people in the US, so 300 million equals 3, and then 1 minus 3, and 1 over 1 minus 3. Then we want to actually get rid of this 3, so we can divide this and this, because of both sides, by 3. We then have 100 million equals 1 minus 3 and over 2, negative 2. We want to get rid of this, so we can multiply this and this by negative 2. We then get negative 200 million equals 1 minus 3n. We want to take away the 1 from both sides. We get negative million and 1 equals negative 3n equals 200 million 1 equals 3n, I guess. And then we can do the log 3 to figure out this more precisely. And once done and divided by log 3, we get 17.4, which means it just takes over 17 rounds. Ta-da!
Let's say you get invited into this pyramid scheme. What are the chances you will be one of the last to join in the 17th round? first off, we established that the 17th round, there are 129 million new recruits. To figure out the numbers of the final round, we take the previous formula and plug in our new numbers, which we now know. 3 to the 17th, because now we know there are 17 rounds included. All in all, it brings us to 129,140,163 over 193,710,244. When you divide these, it spits out the number 66.7, which is actually 66.7%, which means you have a 66.7% chance of being one of the last members to join the group.
Okay, stacking apples. Now let's say you see a stack of apples in a Mega Mart and are wondering exactly how many apples are in the stack. The layers go from 1 on top to 4, then 9 apples. Now, let's use the summation notation to find the number of apples in the stack. So, let's see, what number goes here and what number goes here. So we have about like 15 rows. We're just going to put like 15 here. And then we see that the formula is I to the second power, so we're just going to do I equals 1. And then, 1 to the second power plus 2 to the second power plus 3 to the second power, and so on to 15. If we do this, we will get 1,240 apples all in all. Now, let's use the sum of squares formula to find out the number of apples, shall we? Now, apples equals 15 times 15 plus 1, 15 because of the number of rows, and then 2 times 15 plus 1, because we're using that formula we used before, divided by 6. And then we get 15 times 16 times 31 divided by 6. Once doing the simple math there, we get 1,240 apples. Yes. Retirement investment. You set up a retirement fund and deposit $6,000 each year with a 7% interest. How much money will you have after the last deposit of 32 years later? 6,000 plus 6,420 plus 6,869.4 plus ... all the way to 32. So a to the 32th power. So we see it's a geometric series of 1.07 each time times 1.07. So we have Sn equals 6,000 and then 1, because we just type in the formula, 1 minus 1.07 to the 32th power divided by 1 minus 1.07. And then we just do it, and then we have 6,000 and then 110 times 218, S to the 32, because that's what we're trying to figure out. And then we get 6,601,308.93. We can conclude that the account grows the most in its last year because it makes the most money on its compounded. But what if you wanted to find out how much money was made in the last year alone? Well, we could just do S31 times 6,000, and you type in everything. The full amount is 600,661,308.93. And so we have that amount, and we're basically just going to subtract it from the last year, and we get 48,870.68. If you wanted to write a reclusive roll of how much gets added to the account, it would look like this. This is our little formula. We just plug it in. This would be our first term, our interest, our last term, and our number of terms, and the amount added yearly.